So yesterday we introduced the topic of confidence intervals, right? We talked about all the pieces of the confidence interval, and we said a confidence interval is how confident are you in the true answer, right? And we talked about as your confidence level goes up, 50%, 60%, as you feel more confident in your answer, the thing you would like is more room for error, right? More room for error. If you were gonna guess how many pennies were in that jar, if I said you had to pick one number, you weren't very confident. But if I said, okay, well, I'll give you a margin of error of 100, your confidence grew. 500, your confidence grew, right? So as you get more confident, your um, your as you got more confident, the interval got bigger. Okay. Okay. So the owner of a popular chain restaurant wants to know if completed dishes are being delivered to the customer's table within 1 minute of being completed. So they took whoever he or she took a sample of 75. 60 of those 75 were delivered within a minute. Okay. So what they want to do is they want to use that sample to find the 95% confidence interval for the true answer. We're trying to find the true answer. What percent of all of the dishes are being delivered within 1 minute? Okay. That's the sample is 80%, right? That's just the sample. But what they want us to do is take based off that sample, what is the true percentage of all of the dishes? Okay. So we did population parameter, true proportion of all dishes delivered within 1 minute for completion. Here's the formula we used for this. It's the one proportion Z interval. One meaning one sample. We only got one sample, 60 out of 75. It's proportions, right? It's a proportions problem. Z, because we use Z critical, Z scores, and it's an interval, confidence interval. Okay, there's the formula. And then we stopped right here, right? We stopped right here with our conditions and we checked them. They all checked out. Okay, so the next one is calculations. So those are the first three. 1, 2, 3. Here's the fourth one, calculations. So now what we're going to do is we're going to use that formula. We're going to use that formula and actually get some numbers. Okay? So the first thing is our point estimate. P hat. That's from our sample, right? It was 80%. So we're going to use 0.8 plus or minus Z critical. What is Z critical for this problem? What is Z critical going to be for this problem? Yep, it's a 95% confidence interval, right? And that's what we did yesterday. We figured out how we made a table so that we could easily refer to it. So 1.96, that's the number we're going to use for Z critical. Okay, for 95%, if it's a 95% confidence interval, it will always be 1.96. Okay. Times, now I have the next thing, which is the standard deviation formula from last chapter, right? We don't have P. So we talked about this yesterday. The best we could do is P hat. We don't have the value for P. We know what P is. The true proportion of all dishes delivered 1 minute of completion. But we just don't have that number. That's what we're trying to figure out. Most of the time, you won't have that number. Because if that's the number we're trying to figure out, why would we have it, right? Doesn't make sense. So most of the time, you won't have P. So we'll just use P hat. 0.8 times 1 minus 0.8 over 75 square root. Okay. So we got some crunching to do, number crunching. Okay. So the first thing I'm going to do is I'm going to crunch the margin of error. I'm going to get the margin of error. Okay, that's the first thing I'm going to do. So let's see. Okay, so for the margin of error, let's see if yours matches mine. 0.091. Okay, that's the margin of error. It's a proportion, so it's about 9%. Right, it's about 9%. So now to figure out the interval, where does it start and where does it end? I'm going to add these two numbers. That'll give me the end. And then I'm going to subtract these two numbers, and that'll give me the start. Okay? Okay. That's my confidence interval. No, they have to go in order. They have to go in order. Okay. So what does that interval mean? That interval means I am 95% confident that the true answer, and what does the true answer represent? The true proportion of all of the dishes that have ever been served by these chain restaurants that get to their customer within 1 minute is somewhere between 71% and 89%. Based off the sample, based off that one sample of 75, what I'm saying is I'm 75 or 95% confident that the true percentage for all of the dishes that are served that get to their customer within 1 minute is somewhere between there. Okay, that's what that number represents. And that's the last step. The last step is conclusion. We are 95% confident that the true proportion, and literally you just cut and paste. That's why we do population parameter at the very beginning. So for the conclusion, we literally just cut and paste. Okay. The true proportion of all dishes delivered within 1 minute of completion is between 0.709 and 0.9891. And that's the last step. That's the last step for confidence interval. That's the fifth step. Okay. Now, does your conclusion have to say exactly those words? No, but it should say something similar. I'm 95% confident that the true proportion of all dishes delivered 1 minute completion is between those two numbers. Okay, somewhere between those two numbers. So if someone makes a claim and says, I think it's the true percentage is 65%. 65%. I could say I'm 95% confident you're wrong. I'm 90, based on my sample, if I did my sample correctly, I'm 95% percent confident that you're wrong, because 65% is not within the interval. It's before the interval. Okay? So I don't know if the true answer is closer to 0.709 or closer to 0.892. I don't know which one is closer to, but I'm 95% confident that the true answer is somewhere between there, based off my sample. Okay? So in essence, you're kind of using something small to predict for something big, right? You're using a statistic to predict a parameter, right? And that's how we talked about it yesterday. That's how these polls calculate who's going to win the presidential election or whatever election it is, right? That's what they do. They come up with confidence intervals, and they're able to get pretty darn close to what actually will happen, unless something crazy happens. Okay? So interpreting. So down here is another example of the sentence frame. We are blank percent confident that the true proportion of P in context, right, from that step one, is between blank and blank. Okay. Interpreting. We always interpret the confidence interval. Sometimes they're going to ask you to interpret the confidence level. So interpreting the confidence interval is interpreting that guy. Interpreting the confidence level is interpreting that guy. Right? So they're different. Now, the only time we need to interpret confidence level is if they're asked us to. They ask us specifically to interpret the level. If we do, you can use this sentence frame. Rarely will they do it. But I always put it on there just in case. So if you're going to interpret 95%, what does 95% mean? Right? What that means is if we collect a large number of samples using this method, about 95% of the resulting confidence intervals will contain the true proportion of all dishes delivered within 1 minute of completion. Okay? So we only do this one here if we're specifically asked. We always do the conclusion, though. We always interpret the interval. We only interpret the level if they've asked us to. Okay? So one more time. If I interpreting the interval means, what do those numbers mean? Interpreting the level, what does that number mean? What does 95% mean? Okay, that's the difference between them. Okay? Okay, so let's talk about a couple things before we do some more practice. We kind of talked about a couple of these. Okay, so as my confidence level increases, I'm becoming more confident in the number of pennies that were in the jar. I'm becoming more confident. You guys got more confident, right? What happens to the margin of error? Does it go up? Does it go down? Or does it stay the same? Yeah, why would it go up? You're right. It is going to go up. Exactly. What determines how wide those two numbers are apart from each other? What determines how far apart these two numbers are? The margin of error, right? So a bigger margin of error, what's going to happen to the numbers? They're going to get farther apart, right? And that's what it's saying. Right? We talked about it. The more confident you get, the more leeway I need. So margin of error is going to increase. Margin of error will increase. Okay. Sample size. As sample size gets bigger, so let's say for my last problem, it was a sample of 75. I'm going to do it again, but this time I'm going to get a sample of 500. 500 dishes. What's going to happen to my margin of error? Because you're right, it will get smaller. That's the answer. You're getting there. You're getting there. Why would the margin of error go down? That's the right answer. As sample size goes up, margin of error goes down because there's a couple reasons why. The first one is just math, right? The first one is math. This is the margin of error right here, right? These two guys make the margin of error. What happens in math if I make the bottom of a fraction bigger? What happens to the overall number? It's going to get smaller, right? Yeah, it's going to get smaller. Like if I take a number like 1/2, and I make the bottom of the fraction bigger and bigger and bigger and bigger until it becomes something huge. The overall number gets smaller, right? That's one reason why. The margin of error is going to decrease. The margin of error is going to decrease. As the bottom of the fraction gets bigger, the overall thing is going to decrease. That's one reason, mathematically. The other reason is what happens if our sample size gets bigger? We get closer to the what? We kind of talked about this last chapter. As my sample size increases, what decreases? Variability, right? Variability is margin of error. Margin of error is the variability, right? Margin of error is the variability, right? So as sample size gets bigger, variability is going to decrease, which means margin of error will decrease. Okay, you're more sure of yourself. I'm more sure of myself. I'd rather have a sample of 500 than a sample of 75. I'd be more confident in my answer if I talked to 75 or 500 people, right? If you wanted to find out an opinion about students at Central High School, sure, I mean, if you ask 20 students, that's not very much work. But asking 100 students, you'd feel more confident in your answer. You'd feel more confident in the number of people that you've talked to. One of my pet peeves. So we all have elected officials that are, that go to our state officials go to Sacramento. The elected ones go to Washington, right? Senators, um, House of Representatives, state senators, state assemblymen. And then so anytime they're asked questions like, why did you vote for this? Yes on this. Why did you vote no on that? They say, well, my constituents, what are constituents? Does anyone know what constituents are? Who they are? Who you represent. It's the people you represent, right? So if I'm mayor of Fresno, my constituents are everybody who lives in Fresno. Okay. So anyway, so they vote there. It's like, why did you vote yes? Why did you vote no? Well, my constituents told me to vote yes. Talking to people, I think the majority, talking to people, the majority wanted me to vote yes. I've never talked to these people, so how do they know what I want? Right? They've never talked to me. Who are these majority they're talking to? Right? If I were a good politician, that's kind of an oxymoron, a good politician, but if I were a good politician, I'd want a lot bigger sample size, right? If they are taking a sample, it's very small because I've never been asked any of these questions, right? So that would be a good idea. If I were a good politician and I really want to know what my constituents think, I would take a big sample size and get an idea of what they think. Hey, this bill is coming up for vote. It does this, 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 and this. What do you think of it? Should I vote yes or should I vote no? Right? Because they're not supposed to make decisions on their own. They're supposed to talk to all of us, right? That they represent us. It's a representative government. Republican government means you represent one person represents a lot, right? So that's why. That's so as sample size gets bigger, I can go to Washington and vote yes or vote no because I'm more confident in that, right? But in the end, they just talk to a select few. Sometimes it's not even a random sample they talk to. Sometimes they just talk to their friends. What do you think about this? So it is what it is. But that's the more you talk to people, the more confident you are in your answer. Okay. Okay. So, all right. So let's look at another problem. I want you to do number 3. Do example number 3. Okay. Cell phone users. It's about cell phone users, which I'm assuming everyone is, or almost everyone is. Okay. So I want you to do number 3. I'll give you 5, 7 minutes or so. It's a confidence interval, so you're going to have to go through all 5 things. Okay. And then we'll go over it. Okay, so if you're still working, go ahead, but I'm going to get started so that if some of you are stuck or just to check your answer. A recent poll of 738 randomly selected cell phone users found that 170 of the respondents admitted to walking into something or someone while talking on their cell phone. Okay. Construct and interpret a 95% confidence interval for the proportion of all cell phone users who would admit to walking into something or someone while talking on their cell phone. That's what we're trying to find, the true proportion. So if that's what we're trying to find, that's going to be the population parameter, the true proportion of all cell phone users who have admitted walking into something, let's just say something, while talking on their phone. Okay. Usually that part will be in there. So it's usually you can pull it out. Okay. Test statistic, the same one. Before I did that, I always label anything that I know will be useful. I know it's going to be a confidence interval. So I label anything like N, P hat, right? 170 over 738. Those are the people who have admitted to walking into something or someone, right? That's about 23%. Okay. Conditions, check. SRS of 738 stated as random. 10% condition, well, N less than or equal to 10% of big N. N was 738. Now, I don't have a number for big N, but who is the population? All cell phone users. Yeah, all cell phone users. This is where people get it mixed up, right? There was a question, number 1 question on the quiz was name the population parameter. They're different. Population is who are they? Parameter is what about them? Proportion or mean. Okay? So this is population. All cell phone users. Okay. Is the shape normal? Well, for proportions, we use this check. We always use that check for proportions. Means, when we do that next week, remember it's different. We use central limit theorem. Okay? So 738 times, we don't have P, but we do have p hat, so we'll use that one. So this one's about 169.74. Check. And 77. This one's 568.26. They're both big enough. Okay. Now the calculations. Starts with p hat. From our sample, we know that p hat is 0.23 plus or minus z critical. What is z critical going to be for this one? Yep, same as the last one because it's the same level confidence. 95% is usually the most popular one that you'll see. 98%, 99% are very popular too, but 95% is usually the most popular. P 1 minus p hat, and then 738 on the bottom. Okay. So 0.230 plus or minus, and then now I have to crunch this in my calculator. 0.23 times 0.77 divided by 738 times 1.96. Oops. 0.30. 3%. Okay. So when I add them, I get 0.260. When I subtract them, I get 0.200. So my interval goes from about 20% to about 26%. Okay. Conclusion. Let me move this down a little bit. We are 95% confident that the true proportion of all cell phone users is between 0.200 and 0.260. So based off my sample, the true proportion of all cell phone users that have walked into somebody while on the phone or walked into something while on the phone is between 20 and 26%. How confident are you? I am 95% confident in that answer, right? That's pretty confident. 95% is pretty confident. And so someone asked, why do we have high percentages? Why 90, 95, 98, 99%? Well, if you're doing something, Why not be confident, right? Why do all of this and say, I'm 20% confident that's the right answer? It's a waste of time, right? It's just a waste of time. So we want to make sure that we're really confident in our answer. Okay? So you'll see a question like this. It'll be a follow-up question, and it'll say, someone states that the real answer is 30%. 30%. Do we have enough evidence to say that they're wrong? Because 30% is not within our interval. I'm 95% confident that they're wrong. So you would say, yes, I do have enough confidence. I do have convincing evidence that that person who said 30% was the true answer is wrong because it's not within my interval. Now, if someone made a claim that 22% is the true answer, then you could say, yeah, I have convincing evidence. I'm 95% that they're correct. Not that they're correct. Sorry, that I don't. If someone says 22, you wouldn't call them correct. We never call people correct. We never say you're right. We say, I don't have enough evidence to say you're wrong. So I can't say you're wrong. Are you right? I don't know. It's like in court, right? It's like in court. If someone has a trial, there's a trial. What are the two options the jury has? Guilty or not guilty, right? Guilty means there's enough evidence, we believe you did it. What does not guilty mean? There's not enough evidence, right? It doesn't mean the person didn't do it, right? It doesn't mean you're innocent, right? Innocent is not a factor in the decision. It's you might have done it, but I just don't have enough evidence to show beyond a reasonable doubt that you did it, right? That's kind of like we do. We never say that person's correct. We say we don't have enough evidence to call that person a liar. We don't have enough evidence to say they're wrong. So if someone comes up and says the true answer is 23%, that might be, that might not be. I just don't have enough evidence to say they're wrong. But if someone comes up and says 30% is the right number, I do have enough evidence to say they're wrong, right? They're wrong. That's what it means. So it's kind of like court, where it's guilty, not guilty. There's no such thing as innocent, right? There's no way to prove your innocence.
Innocent until proven guilty.
Well, that's before the decision's made, right? Before the decision's made. That's during the trial. That's the lead up in the trial, right? But once the decision is made, then you're no longer innocent until proven guilty because they've either said you're guilty or not guilty, right? So there's no way of saying I'm innocent. Okay? Okay, so let's see. Do number 4. Last thing we'll do, number 4. I don't think we're going to get to number 5. But do number 4. They actually give you the interval. They've already done all the work for you. There's the interval down there. You just have to answer questions based on that interval. Okay? So a counselor at a large high school wants to estimate the mean amount of sleep that students got the previous night. She selects a random sample of 10 students and asks them to record the number of hours they slept last night. Based on this sample, the 95% confidence interval for the population mean of sleep for all students at the high school is 5.39 to 7.81. Okay, so that means she's 95% confident that the true average hours of sleep is somewhere between 5.39 and 7.81. Interpret the confidence level. That's just the conclusion. That's just the conclusion. Okay? If it said interpret your confidence level, you would use this guy right here. But it didn't say that. It just said confidence interval. That's just the conclusion. Okay? What is the point estimate? Okay, so the point estimate. So remember the margin of error is the number we add and subtract, right? The number we add and subtract. So, so the interval is 5.39 to 7.81, right? The margin of error is the number needed to get from the middle to the edge. And it should be the same here too, right? That's the margin of error. So the first thing we need to do is find where the middle is. That's going to be the point estimate. So you can add these two guys up and divide by 2. That's probably the easiest way to find the middle. It's like when we were trying to find the median and we had 2 numbers in the middle, you add them up and divide by 2. So the middle is 6.6. That's directly in the middle of those two guys. Okay. So now this distance in blue is the margin of error. Just one side. One side is adding, one side is subtracting. So you can just subtract 781 minus 6.6, and you get the margin of error. So the margin of error is 1.21. The point estimate is 6.6. It's directly in the middle. Always will be directly in the middle of the interval. Point estimate will always be there. That's where the point estimate always is. And the margin of error is how far do I need to go from the middle to the edge of the interval. Okay. Last one is it is recommended that high school students get 8 hours of sleep each night. Based on this survey, the students claim that on average, students at this high school are not getting the recommended hours of sleep. Use this interval to evaluate the claim. So the claim is students on average are not getting the recommended. Is that true? Yes, because 8 is not within that interval. I'm 95% confident that the true average is somewhere between 5.39 and 7.81. So based on what I have, I'm pretty confident that they're not getting the right amount of sleep on average. On average. Okay, based off the interval. All right. Okay, so I'm not sure if we're going to do the last one. We might do it tomorrow. We might not. I will definitely want to give you time to do your assignment, so I'll have your assignment ready. And then so if you could ask questions, just like always, Friday, we won't do anything new. All right. No, I haven't finished grading your quizzes yet. No, not yet. Hopefully, definitely soon.